Okay, so now what we're going to do is we're going to try and see if there's a connection between equations, tables and graphs, and see if there's any way we can use them. So we're going to start with a very simple relationship. We're going to say that y is always equal to double of x. So if something's double of x, it's just 2 times that original amount, or 2x. So let's see what that would look like. If x was 1, y would be 2. If x was 2, double that would be 4. If x was 3, double that would be 6. Now we've got that from the equation, but let's put it into a table. If x was 0, we'll put all the x values on the top and all the y values on the bottom. If x was 0, y would be 0. If x was 1, we'd double it, and that would become 2. If x was 2, we'd double it, and that would become 4, so on and so forth. Then we could write some coordinates underneath. 0, 0, 1, 2, 2, 4, 3, 6, 4, 8, so on and so forth. Now, we don't just have to deal with whole numbers, we could deal with other numbers too. So here I've gone up in halves, starting at negative a half. So if I doubled negative a half, I would get negative 1. If I doubled a half, I'd get 1. If I doubled 1 and a half, I'd get 3, so on and so forth. And that gives me another set of values that I could use. In fact, I even doubled 135 and got 270. Obviously, I can't put that on my graph, but it would still be a valid pair. Underneath, I've written the coordinate pairs, negative a half and 1, as we're used to seeing them. Now, in the next video, we'll have a look at how we deal with these sorts of values, but for now, we're just going to look at all the positive ones. So, now once we've got it in a table, we can put it on a graph. 0, 0, there it is there. 1, 2, 1, 2, there it is there. 2, 4, there it is there. And we can put all of these on here, that's all the whole value numbers. And then here's all the halves. Half 1, 1 and a half 3, 2 and a half 5, so on and so forth. Now the big question is, if we graph all of these and draw a line through them, we're going to get a straight line. And when we get a straight line from a graph, it's called a linear graph, or a linear function. It would be a straight line. Now, there's many other connections between equations, tables, and graphs, and we'll learn about some of them on the next slide, because we're going to focus on linear ones for now, but there's many other types too. So, when we have a linear relationship, there are some things that are common to equations, tables, and graphs. For one, a linear relationship always makes a line. And if we look at the table alone, all the run values, the differences between the y values, and all the rise values, oops, that's upside down. That's not the rise value. That's not the run value. This is the run value, and this is the rise value. Okay, so all the run values need to be equal, and all the rise values also have to be equal. They don't have to equal the same number, they just have to all be equal. So I could have all 1s up here and all 2s down here, or all 2s down here and all 1s up there, as long as all these numbers are the same. If that's the case, they will make a line. Now, funnily enough, that yellow line there is the same as this. So when it goes across by 1, that's this run value, it's going to rise by 1. That's the rise value. And you can tell how much the graph slopes just by comparing the rise and the run value. Now, if we look at the equation, we can find out this value in front of x, the coefficient of x, for y. If we know what the rise is, we stick that on the top, and if we know what the run is, we put that on the bottom. Evaluate that value, and that'll give us the coefficient of x for our equation. Now, the other thing in our equation that we can get from the graph and the table is this value here, the y-intercept. The y-intercept's where the graph crosses the y-axis. And funnily enough, that'll be where x equals 0. Here's where x equals 0. Here's the y-intercept. There it's 5. Here it's 5. And if you look at the equation, there it is there. And that's because if x equals 0, this part equals 0, so y must be what that is. But the only bit that we need to know is, if we know where the graph crosses the y-axis, we know that this value here on the end is going to be 5. Or if we know that when the x value is 0, y value is 5, or whatever would go here, that would be the corresponding value in our equation. So quite nifty stuff in order to get between tables, graphs, and equations. Now today we're going to focus specifically on going from a graph to an equation. I'm not going to so much worry about this one. So here's a graph. It's a linear function because we can see it makes a line. So it's going to be in this form here. Now we know that it starts at 4, so that's where that comes from. There it is there. And we know that each time x increases by 1, y also increases by 1. So let's write that over here. There's the rise, there's the run, there's the rise. So you put the amount that it goes up and down on the top and the amount that it runs across between 2 points, and then multiply that by x. Now 1 divided by 1 is 1, times by x is just x. 4 plus x is the same as x plus 4. And the naming convention for linear algebra is that we put the x value first and the y-intercept second. So that was fairly easy. So it starts at 4, and each time x increases by 1. Y increases by 1. Oh, the point, you see what I mean. All right, let's have a look at this now. Again, I'm going to take that off because it doesn't make as much sense now as it did with the way I was going to say it the first time. Now, this time it's a little bit different, because for every 1 that it goes across, it's going to rise 2. So there's the rise, there's the run, and we know that it crosses at 3. So there it starts at 3. 2 divided by 1 is 2, times by x is 2x. That's where the 2x comes from. Here's the 3, and there's the 3. So 2, that's fairly easy. So look at the third one now. This one's a little bit harder. Well, we can see that for every 2 that it goes across, it goes up 1. So if we go down 1 and then go across 2, that'll get us to here. And if we go across 1 and then go across to 2, it'd be over here somewhere. And then we're going to have to try and figure out what happens when it crosses here. Oops, that's not quite right, is it? It's not going to give you the answer that I'm looking for. Yeah, that's a bit better. Okay, so each time in the middle it's going about halfway across. So this line's going to cross the y-axis, this line here, at about 4.5. And each time it's going to, for every 1 that it goes across, it's going to go up half. Or we could also say it a different way, which might be easier. For every 2 that it goes across, it's going to go up 1. There you go. For every 2 that it goes across, it goes up 1. And that's where your half comes from. So there's your half x plus 4.5. That's quite good. This one's a bit harder. Now this time, in the question they've told us, at x equals 0, y equals 4.5. So they've given us this part. So we don't have to work backwards to try and figure out where it is. And y increases by half a unit for every 1 unit increase of x. Now, I'm not sure that this graph is actually correct. So let's figure it out. At 0, it's going to be 4.5. There it is there. Now, y increases by half a unit for every 1 unit increase of 2. So for every 2 increases of u, it's going to increase by 1. Oh, I suppose we can do it by half. It's going to go from 4.5 to 5 for every 1 unit increase. So it's gone up half, it's gone across 1. That's what that said. It's going to go up half for every 1. So for every 1 unit of x, it goes up half. So we've got to be careful now, because that ain't going to be correct. So let's do something a bit easier then, because it's hard to work with halves. For every 2 units it goes across, it's going to go up 1. So we put the run on the front, and we put the put the rise on the top. So for 2 units across, it's gone up 1. So it's gone up, there's the up 1, and there's the across. Oh, it's still a half. Let's get rid of this nonsense that I wrote over here. Okay, so I might put over here, this is the amount that that's the rise, that's how much it's gone up. That's the run, that's how much it's gone acrossways. So that is the run. Might get a darker pen because I can't see that. That's the run, and this bit here is the rise. So we put the run on the bottom, we put the rise on the top. Okay, I think that's as far as I'm going to take you in this. So after you've done that, you should be able to do exercise 11C. Thank you.